Good morning. Today we have to see work done during thermodynamic process. Work done during thermodynamic process. Today we have to see work done in thermodynamic process. What is thermodynamic process? The process in which state of system changes. The process in which state of system changes is called as thermodynamic process. The process in which state of system changes is called as thermodynamic process. Now, consider change in the state of system. Consider change in state of system at constant pressure. At constant temperature. Consider change in state of system at constant temperature. If the graph of pressure versus volume or pressure against volume at constant temperature is plotted, then nature of graph is like this. See here, pressure, volume. State of system changes in different paths. Suppose this one as initial volume Phi, final volume Pf, initial pressure Pi, final pressure Pf, A, B, C, D. Then state of system changes along different paths. आपण या ठिकाणी 3 paths कन्सिडर करतोय. एक पाथ आहे along AB. Suppose this one as path 1. One another path along ACB. Second path and one more path ADB like this. Suppose this one as third path. Consider change in the state of system at constant temperature. Let A, that is Phi, that is initial state of thermodynamic system, B, Pf, final state of thermodynamic system, A, initial state of thermodynamic system, B, final state of thermodynamic system. Then different paths. First, for path 1, pressure decreases from Pf to Pi, pressure decreases from Pf to Pi as volume increases from Phi to Pf. For path 1, pressure decreases from Pf to Pi, म्हणजे इनिशियल प्रेशर आहे Pf, फायनल प्रेशर आहे Pi. प्रेशर डिक्रीजेस फ्रॉम Pf टू Pi as volume increases from Phi to Pf. पहिला पाथ कसा आहे? फर्स्ट पाथ कसा आहे? प्रेशर डिक्रीजेस फ्रॉम Pf टू Pi as volume decreases from Phi to Pf, and therefore area bounded by curve, हा कर्व आहे. area bounded by curve, that is area bounded by curve Phi d a b Pf. Phi d a b Pf. Phi d a b Pf gives total work done. This area gives total work done by system. For path 2, initially volume increases from Phi to Pf. Initially volume increases from Phi to Pf at constant pressure, and then pressure decreases from Pf to Pi at constant volume, at constant final volume. See, for path 2, volume increases initially volume increases from Phi to Pf at constant final pressure Pf, and then pressure decreases from Pf to Pi at constant final volume Pf, and therefore area bounded by curve Phi d a c b Pf. Phi d a c b Pf, म्हणजे हा जो टोटल एरिया आहे, दिस टोटल एरिया गिव्स वर्क डन बाय सिस्टम. अँड थर्ड, हा पाथ. फॉर पाथ 3, initially pressure decreases from Pf to Pi at constant initial volume Phi, and then volume increases from Phi to Pf at constant initial pressure Pi. आपण हा पाथ पाहतोय. For path 3, initially pressure decreases from Pf to Pi at constant initial volume, and then volume increases from Phi to Pf at constant initial pressure Pi, and therefore area bounded by this curve, म्हणजे एवढा हा जो एरिया आहे कोणता, Phi d b Pf gives work done by system. म्हणजे हा जो एरिया आहे हा एरिया काय दर्शवतो? वर्क डन बाय सिस्टीम. दिस इज अबाउट वर्क डन ड्यूरिंग thermodynamic process. During thermodynamic process, work is done along different paths. Path 1, path 2, path 3. For path 1, pressure decreases from Pf to Pi as volume increases from Vi to Vf. मग हा कर्व मिळाला, हा एरिया मिळाला. फॉर पाथ 2, इनिशियली volume increases from Vi to Vf at constant final pressure, and then pressure decreases from Pf to Pi at constant final volume. And for path 3, initially pressure decreases from Pf to Pi at constant initial volume, and then volume increases from Vi to Vf at constant initial pressure. For all these three paths, area bounded by that curve with volume axis gives work done by system. Okay, this is about work done during thermodynamic process. Now, classification of thermodynamic process. Classification of thermodynamic process. Classification of thermodynamic process. First, reversible process. Reversible process. The process in which state of thermodynamic system, suppose this is initial state, this is final state A, B, here P, here V. Initial state of system, final state of system. The thermodynamic process in which state of system changes in reverse direction means change in forward direction is exactly same as change in reverse direction. The thermodynamic process in which state of thermodynamic system can changes in reverse direction, that is forward and reverse directions are same. In this process, but this process is slow. In this case, state of system reverse. State of system changes in reverse direction. What is reversible process? The thermodynamic process in which state of system changes in reverse direction, that is forward and reverse डायरेक्शन्स आर सेम. म्हणजे ज्या डायरेक्शनने फॉरवर्ड चेंजेस होत असतात त्याच डायरेक्शनने रिव्हर्स पण चेंज होत असतात. दिस प्रोसेस इज स्लो and therefore there is no change in internal energy of system, and therefore this process is called as ideal process. There is no change in internal energy and hence this process is ideal process. This is about reversible process. What is reversible process? the thermodynamic process in which state of system changes in reverse direction, that is forward and reverse directions are same. This process is slow process and hence there is no change in internal energy, that is ideal process. One more process, that is irreversible process. Irreversible process. Irreversible process. Irreversible process. The process suppose this one as process pressure volume. Suppose this one as initial state of system, this one as final state of system. Suppose this is forward चेंज. ज्या डायरेक्शनने फॉरवर्ड चेंज होतो त्याच डायरेक्शनने रिव्हर्स चेंज होत नाही. म्हणजे रिव्हर्स चेंज इज अलॉंग दिस डायरेक्शन. रिव्हर्सिबल मध्ये ज्या डायरेक्शनने फॉरवर्ड चेंज होतो त्याच डायरेक्शनने रिव्हर्स चेंज होत असतो. पण इथं ज्या डायरेक्शनने फॉरवर्ड चेंज होत असतो त्याच डायरेक्शनने रिव्हर्स चेंज काय होत नाही. मीन्स द स्टेट ऑफ सिस्टम, अ thermodynamic process in which state of system does not change in reverse direction. Reverse direction. A thermodynamic system, a thermodynamic process in which state of system does not change in reverse direction, that is forward and reverse directions are not same, is called as irreversible process. In this process heat is lost by system. Heat is lost by system and therefore internal energy of system decreases. This loss of heat causes due to, आता इथं जी हीट लॉस होत असते ती कशामुळे होते. वन, that is non-equilibrium state such as free expansion and explosive chemical reaction like this. And one more, that is due to friction, viscosity and other some dissipative forces. This is about irreversible process. Reversible process, irreversible process, ह्या दोघात डिफरन्स काय आहे मग. The thermodynamic process in which state of system changes in reverse direction. In this process, state of system does not change in reverse direction. In this case, forward and reverse directions are same. In this case, forward and reverse directions are not same. In this case, there is no any loss of heat and hence internal energy remains constant. But in this case, heat lost by system and hence internal energy decreases. This decrease in internal energy is due to some other causes. One, that is non-equilibrium state. One more, that is due to friction, viscosity or some other processes. Okay. Now, third one, that is isothermal process. Isothermal process. the process in which the thermodynamic process in which pressure and volume of thermodynamic system changes at constant temperature. म्हणजेच टेम्परेचर कॉन्स्टंट असताना त्याचा प्रेशर आणि व्हॉल्यूम चेंज होत असतो. सच अ प्रोसेस इज कॉल्ड एज आयसोथर्मल. आयसोथर्मल मीन्स ॲट कॉन्स्टंट टेम्परेचर. A thermodynamic process in which pressure and volume changes at constant temperature is called as isothermal process. According to Boyle's law, pressure is inversely proportional to its absolute temperature at constant temperature, and therefore PV is equal to constant at constant temperature, and therefore PI Phi म्हणजेच initial state is equal to PF Pf. That is initial pressure and volume. Product of initial pressure and volume is equal to product of final pressure and volume, like this. And therefore work done during expansion, and therefore work done during expansion from Phi to Pf at constant pressure is work is equal to P into change in volume dV, and therefore work done is equal to P into final volume minus initial volume. Work done is equal to P into dV. फारता इथं work means integration फारता घ्यायचं म्हणजे total work, and therefore total work done, that is integration of P into dV, that is P into change in volume. तो फारता इथं dV करायचं, P into dV, which is equal to, but we know that for ideal gas equation PV is equal to nRT, which implies P is equal to nRT divided by Phi. Put this value here, we get integration of nRT divided by Phi into dV, and volume changes from Phi to Pf. इंटिग्रेशन मध्ये कॉन्स्टंट टर्म बाहेर काढा, which is equal to nRT integration of 1 by Phi into dV from initial volume Phi to final volume Pf, which is equal to nRT into bracket log of Pf minus log of Phi, which is nothing but nRT log of Pf divided by Phi. This is work done during this process. This work during this process, internal energy remains constant. During this process, internal energy of system remains constant, and hence total heat transferred is converted into work, and therefore heat Q is equal to nRT into log of Pf by Phi. This is about isothermal process. Fourth one, that is isobaric. Isobaric process. The thermodynamic process in which volume changes at constant pressure. Thermodynamic process in which state of system change at constant temperature. A thermodynamic system in which state of system changes at constant pressure. Consider an ideal gas. Consider graphical representation. If suppose graph of pressure versus volume is plotted, then volume changes from Vi to Vf. Suppose A, B. इथं समजा व्हॉल्यूम Vi, इथं समजा व्हॉल्यूम Vf. Consider an ideal gas undergoing volume expansion at constant pressure. Consider an ideal gas expands at constant pressure. Let Vi and Vf are initial and final volumes at temperatures Ti and Tf respectively. Let Vi and Vf are initial volumes and final volumes at temperatures Ti and Tf respectively. Then work done during this process. What is work? That is pressure into change in volume, that is Vf minus Vi. Okay, but we know that P into dV is equal to N R into dt. dt म्हणजे change in temperature. Therefore this can be written as N R into Tf minus Ti. This is work done during this process. Now, change in internal energy. Now, change in internal energy. That is del U is equal to change in internal energy. Change in internal energy, that is N into Cv into dt. Cv, that is specific heat of gas at constant volume. dt, that is change in temperature, which can be written as N into Cv into Tf minus Ti. This is change in internal energy, and therefore by first law of thermodynamics, what is first law? That is work is equal to change in internal energy or quantity of heat supplied. That is Q is equal to change in internal energy plus work. Change in internal energy, that is N into Cv into Tf minus Ti. Work, that is Nr into Tf minus Ti. If suppose N is constant, also Tf minus Ti, म्हणजेच हा भाग आणि समजा हा भाग कॉमन काढला तर जागेवर आहे मग Cv plus R. But according to Meier's relation, Cp minus Cv is equal to R, which implies Cp is equal to Cv plus R, and therefore quantity of heat supplied Q is equal to N into Cp into Tf minus Ti. This is total heat or change in internal energy with change in temperature. Thus, at constant pressure, internal energy of system changes with change in temperature. Okay.